we are asked to determine the reactions at supports and the force in member GE of the truss below. This is a 2D truss, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 members. So M is equal to 9. There are 2 supports here, 2 reactions at support A, and 1 reaction at the roller at support D. So we are going to have 3 reactions. And how many joints do we have? 1, 2, 3, 4, 5, 6. So M plus R, 9 plus 3 is equal to 12. The number of unknowns is equal to 2 times the number of joints. The truss is statically determinate. Now, we can determine the reactions at the supports first. The truss is in equilibrium, so I can draw the free body diagram of the entire truss, write down the equilibrium equations, and solve for reactions. This is the free body diagram of the entire truss. These are the dimensions: 4 meters, 4 meters, 4 meters, and 3 meters. Coordinate frame next to the free body diagram. Counterclockwise is always positive. This is joint A, B, C, D, E, and G. I'm going to draw the external forces: 400 Newton, 1200 Newton, 2 reactions at the pinned support AX and AY. So the pinned support, like a hinge, allows rotation to occur, but no translation. There are going to be AX and AY that prevents it from translation in X and Y axis. If I look at the roller can roll away, so we are going to have translation in X axis, and we are going to have rotation, but the roller prevents the structure from jumping up or down, so we are going to have a reaction force that prevents it from movement in Y axis. Now I have the free body diagram. I'm going to write down the equilibrium equations. Equilibrium equations: sum of forces along x-axis equal to 0, sum of forces along y-axis equal to 0, and sum of moment about a particular point is equal to 0. Counterclockwise is always positive. I'm going to start with the moment equation. I'm going to pick point A to get rid of AX and AY. So sum of moment about A will be equal to 0. What's the definition for moment? Force times distance is starting from the point of interest perpendicular to the line of action of the force. Counterclockwise is positive, clockwise will be negative. So it's going to be minus 1200 Newton times 8 meters clockwise, so it's negative, plus dy times 12 meters, it is counterclockwise, so positive, minus 400 Newton times 3 meters, it is clockwise negative, left hand side is equal to 0. So this is one equation, only one unknown. I can solve for the only unknown. dy will be equal to 900 Newton. Sum of forces along x-axis is equal to 0. So AX plus 400 Newton will be equal to 0. I can solve for the only unknown. AX will be equal to minus 400 Newton. Negative sign means that AX is toward the left-hand side, opposite to X direction. Sum of forces along y-axis is equal to 0. So AY minus 1200 Newton plus dy is equal to 0. I already solved for dy. dy is 900 Newton. So there is one equation, one unknown. I can solve for AY. It will be equal to 300 Newton. I'm done. I solved for all the reactions at the supports. Now I need to determine the force in member G. So I'm going to take a cut that passes through member GE and subdivide the truss into two parts. The entire truss is in equilibrium, so both parts of the truss has to be in equilibrium. I'm going to draw the free body diagram for only one part. I'm going to consider the left-hand side or the left part, write down the equilibrium equations, and solve for the unknown, which is the force in member G. So I'm going to draw the free body diagram of the left part. This is joint E, joint G, joint A, joint B, and joint C. And this was my cut. I have to draw all the external forces. I already know that AX is equal to negative 400 Newton, so it has to be to the left-hand side. 400 Newton, this is AX. AY was positive 300 Newton. I have this 1200 Newton external force, and I'm going to draw the forces. This is the force in member GE. This is the force in member GC, and this is going to be the force in member BC. I'm going to draw the coordinate frame next to my free body diagram. Again, counterclockwise is positive, and I'm going to draw all the dimensions. 4 meters, 4 meters, and this is going to be 3 meters. So this is the free body diagram. Now I'm going to write down the equilibrium equations, and this is the method of section. Equilibrium equations, again, sum of forces along x-axis equal to 0, sum of forces along y-axis is equal to 0, and sum of moments about a particular point is equal to 0. I'm going to consider point C. If I consider point C, I see that the force FBC, the force FGC, and the force 400 Newton pass through point C. They are not going to generate any moment about point C. So the only forces that generate moment is 300 Newton and F in member, or the force in member G. So sum of moment about point C is equal to 0, equilibrium equation, and I know that counterclockwise is always positive. So I'm going to have F GE times the distance perpendicular to it starting from point C. It is going to be 3 meters clockwise, so negative, plus 300 Newton times the distance starting from C perpendicular to the line of action of that force 300 Newton, 8 meters. It is clockwise, so it has to be negative. Equal to 0. I have one equation, one unknown. I can solve for the only unknown. The force in member GE will be equal to 800 Newton.